Okay, we're moving on to timelines, and this is one of my favorite parts of finance mathematics, where we get to look at things and things change over time. So there are going to be multiple deposits, withdrawals, the interest rate could change, and we're going to put it all in a timeline. And this, as I say, I think this is a bit more exciting. So we're going to use all the stuff we've used before, and mostly going to be compound interest as well. So let's read through our scenario and see how we can draw a timeline to help us with it. 8,000 Rand is deposited into a savings account. 2 years later, okay, that's going to be important, a further 14,500 Rand is deposited. Okay, 5 years after the account was opened, so keep note of the wording here. 5 years, but not 5 years, but 5 years after the account was opened, 6,000 Rand is withdrawn. Okay, 6,000 Rand is withdrawn. Calculate the accumulated amount in the account at the end of 6 years if the interest paid on the savings is 7.5% per annum compounded monthly. Wow, so there are lots of bits of information here. In fact, so many I'm running out of colors. So the end of 6 years. And what have we got? 7.5%. What color haven't I used here? Bright red. 7.5% per annum compounded monthly. Okay. Excuse me. Let's see how we can put this all in a timeline. So let's start with the timeline. Let's go. Thank you. So we've got a timeline of when things happen. We're going to start at T0. That's when we're starting, right at the beginning. And what happens right at the beginning? We deposit 8,000 Rand. So we're going to say up here, let's put in 8,000 Rand. 2 years later, so on our timeline, we can look and go, okay, 2 years later at T2, because T1 is at the end of the first year, T2 at the end of the second year. So at the end of the second year, 14,500 Rand is deposited. So we put in another 14,500. 5 years after the account was opened, so in other words, at T5, so I'm just going to keep my scale vaguely reasonable here to go T5, 6,000 Rand is withdrawn. Now there are two distinct ways of saying that you've withdrawn money. You can write minus 6,000, or we definitely don't want to write 6,000 because then it looks like we're putting it in. So we need to somehow show that it's coming out. Another way to do it is to put it in brackets. To go, look, it looks different, it's coming out, or to do minus. Up to you. So either that or minus 6,000. As you can tell by me putting the bracket one first, I prefer that one. It sticks out as a withdrawal, but hey, really up to you. Calculate the accumulated in the amount in the account. Again, we got the amount in the account at the end of 6 years. So this whole charade finishes after 6 years. So this is our accumulated amount here, right at the end. The interest paid, quite a lot going on, right? The interest paid is 7.5% per annum compounded monthly. So what we can say is, I'm just going to draw this with a kind of a dotted line down here to say, for this whole time, the interest rate is 7.5% per annum monthly, because we're going to need to do that. Okay, so now let's work out how much money there is in the account. And we're also I'm going to show you a nice way of saving time in the calculator in this one as well. So our accumulated amount, we went green for that. So our accumulated amount is, and this is interesting, the 8,000 Rand we're putting in the account for the whole time. Then we're going to add the 14,500 Rand that we're going to invest from T2 to T6, so for 4,000, for 4 years at least. And we're going to take out, so we're going to subtract the 6,000 Rand and all the interest it accrues. Okay, quite a bit. Let's see how we can put this down and have this ready. So our accumulated amount is this 8,000. Okay, the 8,000 that we're going to invest for 1 plus I to the n. So our interest rate is always 0,075 over 12, because it's monthly for 6 years means for 72. And we can add in this 14,500 Rand, 14,500, 1 plus 0.075 over 12. And that one's for T2 to T6, that's 4 years. Monthly is 48 months. And what we're not going to get money on is this 6,000 Rand. So we're going to subtract 6,000 Rand. And we're going to lose out on all the interest that money could have earned us. So we're going to subtract 6,000, 1 plus 0,075 over 12. And it would have earned interest for a year. So for 12 months. Okay, now the calculator. Oh, that was behind me, right? Now the calculator trick. So let's get our calculator up. Hopefully that's come up. And let me check. And on our calculator, we're going to, do you notice that in our equation, yellow is free, this bit in the brackets is always the same. 1 plus 0,075 over 12. So let's put that into our calculator. I'm going to scribble what I'm doing down here as well with the calculator, hopefully above my head. We're going to take that amount. 1 plus 0,075 divided by 12. Okay, so that amount there always comes up, that yellow block. So let's store that in a variable. So what we want to do is we want to go tell the calculator, let's store that in a variable that we can call A. And what I find useful is to actually write A above here, so when we have more of these, we can keep track of them all. So we want to store it in A. Now the store button is here, it's above the RCL. So to get there, we're going to have to go shift that button. So to do the store, we're going to have to go shift plus RCL. That's the calculator part. And then to get it into A is above this button, but it's on the alpha. So in other words, this is like a shift store to get there. And that's, so I'm going to go shift store, telling it that I want to store it somewhere, and I want to put it in A. Now A, we have to write alpha to get these ready ones here. Let's put these in capitals, alpha, and then press where that A is. So A, so on that button, that one there looks like that. So we're going to alpha A, and it says great stuff. So let's just run through that again. We've got 1 plus 0,075. And yes, this is definitely worthwhile doing. Feels like it's taking a long time this first time. It's really going to save us time, and it's going to make what we do look a lot easier in the next step. So we put that in equals. We go shift store. Where do we want to store it? In A. So I'm actually wrong there. We didn't have to press the alpha A there. So all we have to do, our calculator things were shift. And then the next one was store. Although the button says RCL. And then the next thing we have to write is A. Although the button looks like that. So now that's in A. So if ever we write alpha A, we get that number. So here's the magic of it all. This whole long equation that we've got, or not equation, this formula we have to substitute in, becomes easy on the calculator. So 8,000. Now we don't have to write that whole thing. We just write alpha A to the power of 72 plus 14,500 alpha A to the power of 48. Okay. Minus. It's a lot easier to keep track of than having a whole lot more brackets and fractions. Minus 3,000 alpha A to the power of 12 equals, and there's our answer. If we made a mistake and went, oh, whoopsie, we wrote in 8 too many zeros here or something, it would be easy to keep track of, oh, this part was that first part, etc. So we've got 25,617. 25,617 and 83 cents. And there it is. So part of the key was that calculator. That's why I wanted to spend a bit of time on it. Here it is. I'm just going to remove it so we got space for that next one. And we'll practice in the next one as well. In fact, pretty much every single timeline question will be using this little trick. So we've got a few to practice and get into it. Okay, that's that one. We can get rid of that and say goodbye.